Hey DEFCON, this is Rinzo from SEKTOR7. I'm really glad to be here, and today in this quick video I'm gonna share with you some interesting technique I have learned some time ago that is about hiding your payload in the process memory. So let's jump straight into the source code. So originally I read about this technique in a paper by Frank Bloch and Ralph Palutke. And the technique is really simple. We create a file mapping which is backed by a page file, and then we map a view to that mapping so that we can use that memory, which is done here. So basically I take some fake random bytes which are pretend to be a payload and just copy them into this memory region. And now if I want to hide that payload, I just unmap the view, okay? And that's it, basically. If we want to reuse that, that payload, then we have to remap the view again to our process. So let's take a look at Process Hacker and how it works in reality. So let me start the guy. So implant, and let's take Process Hacker to see. So we have mapped this memory region. It is here, okay? It doesn't contain anything currently. After we copy the bytes, the payload is here, so to speak, payload, of course. And then I do unmapping. So now if I try to reread the memory, I get it is failing because this memory region is gone, okay? And actually it is it's 568, it's here, it's marked as free. Let's see what happens if I remap this view again. And as you can see, the payload is still there. All right. So how can we weaponize it? Let's do that. So for that, I'm going to use another example, which is Ninjasploit, which was about hiding your payload against Windows Defender, which is doing some memory, like live process memory scans, which are triggered by specific functions, for example, create process. So in this example, I'm going to use really simple calc shellcode. So this payload is going to call create process, which will then pop up our calc. And in original technique, Ninjasploit was actually hooking create process internal function, which is called by process create process. The hooking technique I'm using here is utilizing page guards. It has its drawbacks, but just for this example, I'm going to use that one. So for the page guard, I'm registering my own handler for these exceptions. Set up the whole memory page to be, so to speak, secured by a page guard. All right, and then I call a go function which creates the mapping, maps the view on that mapping. Then I decrypt my original payload, the calc one, copy that into this memory region, I clear the original payload from the memory, and then I create a thread with my payload. So from that point, the payload takes control and tries to create a new process by calling create process. Okay, and if that happens, the exception occurs because of the page guard, and my handler will take over that. Will take care of that, and basically it will call my own create process internal function, which unmaps the view. So at this point, the payload will be not present in, so to speak, in the process memory. I call it the original create process internal function. Takes some time just for us to view what happens inside the process hacker, and then remap the memory again so we can see it if it's there still. All right, and that's basically everything. So let's go to compile it and let's run it. So we have, so calc popped up, that's good. So let's see, we have this memory region 213E0s, and it's not here. Okay, it should be somewhere in here. Yep, it's here. And let's wait for the memory region to get back. And yep, it's back, and as you can see, our original payload is there, right? So that's it. Thank you for watching and enjoy the conference.